So here we see the connection where we want to configure the RN2903 LoRa module for the right channels and the right modulation scheme, and the connection through to the RN2903 on pins 6 and 7, which is TX and RX UART. They are the serial commands that are sent to the 2903 to program it by ASCII commands. Now, you can either use a micro with a USB serial tunneling, so that looking at the PC, the micro looks like a UART, and then sends the serial data, tunnels it all the way through to the RN2903, and you can see the baud rate is 57600 baud, and N for no parity, 8 for 8 data bits, and 1 for 1 stop bit. Typically CTS and RTS signals are not used, but TX and RX are reciprocated from the RN2903 to the TX and RX of the micro UART. And you can see the RN2903 is powered by 3 volts, not 5 volts, 3 volts, and also the TX and RX signals must be 3.3 volts CMOS logic levels. So you can either use a micro, or you can also use a 3 volt USB serial to USB cable, exactly the same, 57600 baud, no parity, 8 data bits, 1 stop bit, a USB to serial cable. The software we will use on the PC is called the LoRa Dev Utility. A little bit about that in a moment, but as you can see the connections, 3 volt 3 is required for the RN2903. Now sometimes the USB to serial converters will have a regulator on board and allow 3v3 volts to power the RN2903. You do need about 100 to 200 milliamps to power the RN2903 if it is transmitting. Maybe not so much in programming and configuration, but if it is transmitting, it needs around 200 milliamps possibly. And as I repeat, 3 volt CMOS logic levels for the TX and RX UART signals.